In the previous videos, we have learned what is multi-threading and how it is different from a process. And we understood the logic part and the data part, and we actually seen why multi-threading is beneficial. So we can run things in parallel, the independent things in parallel. So it is going to save a lots of time and it is going to make the hardware reusability much better. And also we have learned our first multi-threaded programming. And today we are going to learn, let's say you got the concept of multi-threading, you like that, and now we are going to implement a e-commerce website. So let's keep it as simple. Our e-commerce website is going to sell three products. We are going to sell, close this one. We are going to sell a Pixel 10 Pro, iPhone 17 and Samsung S25 Ultra. And inside our website, the user can able to do excuse me, user can able to do only three operations. Either they can read the spec, or they can buy a phone, or they can compare two different phones. So they cannot compare three phones. These are the three operations we are giving as an option. So it is simulation. So we are actually, I used AI to create the simulation, and here the user action is actually coming as a JSON data structure for us. So if you see, uh, the user name is going to be the key. Let's say Alice, what Alice has done on our website. Initially, she actually did the read spec for iPhone 17 Pro, and she was reading it for 3 seconds. And then she's buying iPhone 17 Pro, and the transaction, the bank transaction, the money collection, and everything took 10 seconds. So after collecting iPhone 17 Pro, she read spec about Samsung S25 Ultra for 4 seconds. So you can see the third argument time is the 4 second. And similarly, Bob, if you see, Bob actually reads spec for iPhone 17 Pro for 2 seconds, then reading the spec for Samsung S25 Ultra for 3 seconds. Then Bob buys iPhone 17 Pro and the transaction took 6 seconds. And then he is comparing Pixel 10 Pro with Samsung S25 Ultra, and the comparison actually taken him 3 seconds. So similarly, we have 10 users, and 10 users have 3 or 4 operations they have performed in our website. Now we are going to process this simulation in a program. Let's say this is our e-commerce website, and because each individual users, they are not going to interact with one another, right? So if you make Bob wait for Alice to complete their task, Alice actually taken 10 plus 3 13 plus 17 seconds, and Bob to start his first operation, he has to wait for 17 seconds, which is not a good user experience, right? You want to serve multiple users in parallel. So we are going to use multi-threading here. And every user, moment we saw one user, we are going to create a new thread for the user. And the user action is going to be handled sequentially, because Alice is not going to read a spec for iPhone 17 Pro and parallelly buy iPhone 17 Pro. So inside a thread, the operation is going to happen sequentially. But when Alice is doing this operation, she is going to read iPhone 17 Pro 3 seconds. Parallelly, Bob will be reading iPhone 17 Pro. So both threads will running on two different hardware, and they are going to do their operation sequentially on independent machines. Let's see the implementation here. I have created the code already, and this is our inventory. So okay, so we are going to parse this JSON data structure, right? So we need to import JSON for that, and as you know that threading we need, because threading library is the one we are going to use to create the Python threads. And time, we are going to use time to print the log. So user action, whatever user is doing, we are going to print that in the console, so you can see what is actually happening in a sequential. Then this is our inventory. We have 3 mobiles, and we have 2 Pixel 10 Pro and 2 iPhone 17 Pro and 3 Samsung S25 Ultra in our inventory. And these are the spec for those particular phones. When user wants to read a spec, we are going to give this data. Don't think much about it. Fine. And we create a timestamp function. This timestamp function is going to give the time from start of the program. It is not going to give the wall clock time, so we can able to see a sequential order of things execution there. So the start time is calculating the current time when the program starts execution, and timestamp actually calculates the current time minus start time and sends it back. If an event is happening at 20th second of the program execution, it is going to return 20.2 or 20.0 as a response. And purchase log, when somebody purchases a mobile, we are going to store that here, because based on the purchase log only we are going to deploy, we are going to dispatch the product for them. So it's an e-commerce website. When somebody buys, we have to give them the product, right? So we need to know who actually buys the product, and I'm going to have a new variable purchase log, which is going to keep who bought what. Okay, and this is the threaded function, like the multiply function we had in the previous program. and this process user activity function is going to process every user's activity, and this function is going to run in every different thread, but the arguments are going to be different. We will see that in a moment. Before that, we will see the main thread. So in the main thread, the main function actually reads the e-commerce simulation JSON file, and it is loading the data into the data variable. And initial inventory, I'm having a copy of the inventory, because whenever somebody going to buy a phone, I'm going to reduce the number of inventory for that particular phone, right? So I'm going to keep an initial inventory as a snapshot, because I want to compare what has happened in the meantime. And threads, we are going to create multiple threads. So we have 10 users, and we are going to create 10 threads, one for each user. And all the threads, we don't need to name them thread 1, thread 2, thread 3, because we are not going to process independent of each other, right? So we are going to create a list which is threads, and I create a for loop. The for loop actually takes user and activity from the data user. You see the data structure here, and users, data of users is an object. So this object has a key and a value. So key is the name of the user, and value is an array of actions. So that's what we are taking here from data of users of items. So we are taking every key value pair as a item from the data structure, and then storing that user key into the variable user, and the activities into the variable activity. And inside the for loop, I'm creating a new thread. I hope this is clear, or else once again I will iterate it. So you can see data of users of item. In every iteration, we are going to have a item of Alice, comma, or the name, comma, the activities, and name will be stored into the user, and the activities will be stored into the activities variable. Hope it is a little bit clear, or else you have to learn about how the Python dictionaries actually function. And then we are creating a new thread. For creating a new thread, we know the syntax is threading.thread. Let me close this one. Yeah, threading.thread, and we have to pass a target function. Target function we have created previously. We are going to look at the content in a moment, and we are passing the target function process user activity, and the argument it is going to take is the name of the user and the set of activities he has performed on our website. So we are passing both as a tuple in the args argument, and we are appending the thread into the threads data structure. So you will remember, I hope you remember this, because moment you create a thread, the thread is not coming to alive. The thread is not going to execute right away. So we create all 10 threads, and we are storing the objects into a Python list. After that, it is waiting for, okay, it is printing the initial inventory just for our convenience in the execution time, and then it is telling how many threads are actually created. Then it is waiting for user input, like it is printing the current status. Okay, I am ready to execute the simulation, are you okay? So when I press enter or any key, it is going to continue the execution. Here actually the start happens here. So we got the threads list, right? So we are iterating every value, every object into the list, and then we are calling start function of that one. So this for loop is actually creating every thread into alive. So we created 10 threads previously in this for loop, but those threads were not running, and this for loop dispatches them one by one. So if there are free CPUs in your machine, each CPU is going to take one thread and start executing. And okay, sorry, the start actually executes, it is dispatching every thread to every CPU, and after dispatching all the threads, it is waiting for every single thread. So the main thread's job is simply create 10 threads and start those threads and wait for those threads to complete. Once they complete, we are printing the results. So what we are printing? We are printing how many number of purchases actually happened, and we are printing who bought what. Then we are printing what is the initial inventory, what is the final inventory, and then we are printing total number of phones sold, phone wise, like how many iPhone 17 sold, how many Samsung S25 Ultra sold, and how many Pixel 10 Pro sold. We are printing the inventory details at the end of the main thread. So now let's examine what is actually happening into the user processing user activity. So as I told you, we are going to have only three possible options, right? Like user can able to do either buy a phone, or read a spec about a phone, or compare two different phones. So every object, if you see, has three values: the action, what user has performed, and the action on what. If the user is reading a spec, we need to know he is reading spec of which phone, right? So that is the argument for this particular action. And the third one is time, how long user actually did that action. So user is opening your website and looking at it, he will not immediately click and go, like he will be reading the data for some time, right? So this is the amount of time user took to complete that particular task. Okay, so we parse the activities, we take the three data from that. So we take the action, we take the arcs where the action is performed, and the duration, how long it has taken. So then if the action is only reading the spec, so we are taking which phone is reading the spec. So we are printing the console, user is reading the spec of this particular so and so phone, and what is the spec. And we are actually sleeping for the duration. User actually did the operation for so long, right? So this thread is going to wait for that many amount of time. It is a simulation. So it is kind of showcasing or simulating the amount of time user has spent as a wait time. So after the wait is complete, it is printing done, spec read is over. So once this is done, it is going for the next activity. So we have a set of activities. If you take Alice has performed 3 activities, and we are iterating each activity in a for loop. The first activity is read spec. So it came inside, took the action is read spec. So this particular if block got executed, and then the for loop goes to the next activity. Next activity is buying phone. So next action is buying phone. It is not going to come into read spec, no comparison, it is going to come into buy phone. So while buying your phone, which phone you are buying, we are collecting the argument, and we have to sell only when we have inventory in our stock, right? We cannot simply oversell. When we have only 2 iPhone Pro, we cannot sell to 4 users. If we sell 4, how can we ship? That is a bad for the e-commerce business, right? That's why what we do is we actually calculate what is the stock of that particular phone. We take the inventory of the phone, and then we are printing for the user for our convenience. User wants to buy this phone, and currently the stock availability is so and so. Okay, and then we are checking if stock value is less than 0. If there are no stock, we should not actually go into the purchase process, right? We should not initiate the transaction, we should initiate the money crediting operations and all. So we immediately say the product is out of stock, we are not going to sell you this one right now. Suppose we have stock which is more than 0, we have some phones in our inventory, then we are going to initiate the transaction. Initiating transaction is something like asking user to enter the credit card details and waiting for the OTP and doing all the transaction, money crediting and everything. So this will take some time, and that's what we have kept here. The transaction time is kind of 10 seconds for Alice. So here we are going to wait 10 seconds for the transaction to complete. Once the transaction completes, we are reducing the number of stock because we got the money successfully. It means we are going to ship this particular phone to the user. So we are taking the phone out of the inventory. So we reduce the value of phone inventory, the stock value -1, and storing that back into the inventory. Because when the next user comes into picture, it has to reflect the new inventory value. That's why we are reducing the stock and storing that back into the inventory. Then we are printing in the console, user has purchased this particular phone, right? And similarly, the third operation, if you see comparison is going to perform on 2 different phones. So phone A and phone B, we are taking 2 arguments, argument 0 and argument 1, and then we are simply printing comparing phone 1 and phone 2, and amount of time user has taken to compare that, we just wait for that moment, and then we are printing comparison done. So hope this code is kind of clear, right? So what we have done, the main thread created 10 thread and starting those threads, then waiting for the thread to join, and at the end it is printing the final set of transactions. And inside the each thread is going to run 2 independent machines or independent CPUs you can consider. So it is going to process 3 operations. One operation is reading the spec, user can read a spec. Other operation is comparing that spec, so comparing 2 phones. So in both cases, what it is going to do, it is just printing message for us to see in the console, and then going to wait for certain amount of time where user has spent those much amount of time there, and it is going to print done. So if it is a buy operation, it is going to print user is buying a phone. Additionally, it is reducing the inventory because we don't want to oversell. The code is simple, right? Maybe the code number of lines, if you see, it is more, but actually the concept is very simple. You can walk through it one more time to understand. Let's execute this code and see. Let me clear the console and seeing into e-commerce solution. Yes, now Python, and the problem is e-commerce, no log, not running for some reason. What is the issue? No such file or directory, code so and so, so and so, so and so. it cannot able to find the JSON file inside this particular directory. Why so? Because it is trying to, okay, the path is hard code. I don't want to hard code. So let me remove this answer. Instead, let me import path library from pathlib import path, and here I'm going to get the path of this particular file, and from that I'm going to calculate the path of the JSON file. So it is going to be path of parent. Yeah, this is correct. So we are getting the path of this current file, the current program, and the program's parent is the directory where the program is actually residing, and in the same directory we have the simulation JSON. So we got the file. Now if I run, it should be able to run without any error. Let me run. Okay, got it, right? It is running. So it is printed initial inventory. We have Pixel 10 Pro 2, iPhone 17 Pro 2, and Samsung S25 Ultra 3. So it has created 10 threads, but threads didn't start execution. It is waiting for me to get the confirmation. Let me print enter. Okay, it started execution. So if you see, Alice started reading spec, parallelly Bob reading spec, and Diana, Charlie comparing Pixel 1 on. If we see here, first operations, right? So Alice started reading spec, Bob started reading spec, and Charlie started comparing, and Diana started reading spec. You can see. So similarly, all the threads are running parallelly. So Bob is not waiting for Alice to complete all the 4 tasks. So that's the benefit, that's the beauty of multi-threading. So all your users are currently being processed in parallel. That's why we are going for multi-threading. Okay, now it has taken wait time, it has done like every operation. Yes, Alice wants to buy iPhone 17 Pro, Bob wants to buy iPhone 17 Pro, many people wants to buy, the transaction is so good. So yellow means these are the transactions talking about buying operations. So I have used a special color here. If you see at the top, not here, in the, yeah, buy operation, I'm printing with yellow color, the both print. So if it is yellow, there's a transaction. So it means we have made a good sale. So we should be happy because e-commerce successful. All the inventory probably would have sold out. Let's see how much is sold. Like we have many people bought. Okay, nice. And what is our initial inventory? Pixel 10 Pro 2, iPhone 17 Pro 2, and Samsung S25 Ultra 3. And the final inventory, we have Pixel 10 sold out, iPhone 17 Pro we have one remaining, didn't get sold out, and Samsung S25 Ultra we just sold only one and two are remaining. But if you see Pixel 10 Pro, we have sold 3 products. Our inventory we had only 2, but actually we sold 3. We made 3 transactions. We got money for 3 Pixel 10 Pro. And iPhone 17 Pro, we just sold only one. Inventory got reduced to only one. But if you see here, we actually sold 3. Okay, so just by reducing one phone from inventory, we sold 3 products. And Samsung S25 Ultra, only one we sold from inventory, but total number of products sold is 4. So we wanted to avoid overselling. So that is what we have done here. So we actually taken the stock value, and then we are reducing the stock value from the inventory after user makes a purchase, but still we oversold those products. Why we oversold? Let's go and see the law. Let's take something from here. Okay, Alice wants to buy iPhone 17 Pro. So we have stock 2 at the time. When Alice wants to buy, so this is the code. We have to compare the code side by side into dry run. So this is the line. Alice wants to buy iPhone 17 Pro, and this is where buy. So this thread, Alice thread running on the first CPU, we got the stock. The stock value is 4 at that time. So Alice is going to make a transaction. Before making transaction, we are checking stock, and we have 2 values, so 2 phones in the stock. So we are good. We are going ahead with the transaction. Transaction is taking us some 10 seconds. And when Alice is completing the transaction, yes, Alice purchased iPhone 17. But if you see in between, here Alice wants to buy, the stock value is 2. Parallelly, Bob also wants to buy iPhone. So both transactions, because these 2 threads are running in 2 different CPUs in parallel, both initiated their buy operations in parallel. When Alice read the stock, it was 2, and Alice didn't make the transaction. Alice didn't complete the money transaction. So we didn't rewrite the inventory with the reduced value. So when Alice is making the transaction, Bob wants to buy, and Bob thread also reads the inventory, and the inventory still says 2. So Bob took the value 2 for granted, and when Bob completes the purchase, actually Bob transaction take faster than Alice transaction. So Bob reduces 1 from the initial stock value, which is 2, and writes it back to the inventory is returned as back to 1. But Alice code, if you see, Alice code currently in the wait state, and when Alice completes the transaction, Alice completes here, right? At this point, what Alice does, Alice is reducing 1 from the stock. Alice is not reducing from the inventory value. She is reducing from the value previously she has read. This value is read before Bob initiates transaction, and when the transaction is in process, Bob initiated a transaction and completed transaction and rewritten the inventory. But Alice doesn't know that. The code which is handling Alice's transaction doesn't know that. It is still working on its local variable. The local is nothing but stock. Then the stock value is 2, and it is reducing 1 from the stock value and writing it back into the inventory. Inventory is already having 1, and now this thread, Alice thread, is again writing 1 back to the inventory. So actually inventory, the value got reduced only by 1, but the product got sold to Alice as well as Bob. As an e-commerce company, you collected money from 2 customers, Alice and Bob, but actually you reduced only 1 inventory from your stock. This is a biggest problem in distributed computing or parallel processing. When you have multiple threads, multiple execution units or the logic units working on a same data structure, same global data, there can be discrepancy. One may override the value which other has read. So here the data read by Alice thread is invalidated. By the time he is going to use that for calculating new inventory value, the data is already wrong. When Alice read the initial stock value, it is correct, but when they are going to write, it is wrong. So the value can change when you are currently processing it. That is the biggest problem in multi-threading. And in the next video, in the upcoming videos, not only next video, there are multiple ways to avoid this kind of problem. We are going to learn about critical section, we are going to learn about logs and serialization. So we actually created multi-threading for parallel processing, but in parallel processing, some places we have to keep them in serial. We don't want parallelism to happen everywhere. So how are you going to control sequence at some places, but still we are going to leverage parallel processing at other places? And what is the trade-off to have, like what sequence is better? All these things we are going to learn in the upcoming videos. And these kind of concepts are the fundamental for distributed system design. You go to any product company, they are going to put you in a system design interview, and they are going to ask you to design a system which is going to run on multiple machines across multiple data centers, across multiple continents, and they are going to work on a shared data value. The state, the data, the database, if there are multiple replicas, still they are going to represent single state. So your design decisions, your job there is to be, how are you going to have a parallel processing which is going to utilize all the available hardware, which is going to be blazingly fast for all your customers, still not getting into these kind of discrepancies. How are you going to maintain a single state when the logics are in parallel? This is the ultimate challenge for every big company, including Google, Microsoft, Facebook. Everyone is solving these kind of problems day in, day out. And to learn all those hard concepts, all those detailed, brain-breaking concepts, the fundamentals should be strong. And this multi-threading, we start from here. So this is the very first place where we start to learn multi-processing on a same data structure. Okay. Hope you like this video. Hope you learned something new here. So you would have already learned about mutexes, logs and everything, but you wouldn't have felt why it is necessary. If there were no logs, what is going to happen? We didn't learn about log, how logs are going to solve the problem. But to learn a new concept, first you have to understand what is the problem it is solving. Right. So once you internalize the problem, then the solution will actually make sense. You can learn a concept, but until the concept makes sense, you are not going to remember it. But if you know the problem, and if you know how the problem is solved using the solution, you don't need to remember, you don't need to memorize the solution. The solution will click. So you can derive the solution in the interview right away. You can think of a problem, you can explain why the problem is happening and what is wrong there and how a new solution is going to actually solve the problem, and the concept will naturally evolve in your mind. That's why we are learning in the fundamental level we are learning, we spend so much time to learn the problem first. So we just came into the very famous transaction problem. So this is called the transaction problem. We came into the transaction problem. Please watch it again if you don't understand it. Look at the code, read the code, and try to internalize where the transactions are overlapping, why the data is correct at one point but wrong at the other point, when that transition actually happens. Try to internalize all these things. It is going to be very beneficial for you in the long run. Whatever concepts you are going to learn in the future, this is going to be the fundamental. And please don't forget to give a thumbs up and subscribe for the channel to learn more detailed concepts. It's not hard concept. I will not say nothing is hard if you understand it very well. So, a complex problem is nothing but a beautiful arrangements of multiple simple problems. You learn every simple problem one by one, one by one, one by one, and see the connections. You can easily break down a complex problem. So, to learn a concept in such a way, without memorizing, without by heart, without understanding, you know something, right? You may able to answer in an interview, in a 10-minute interview, but you may not able to internalize. You may not able to implement that in a real product, or you may not able to convince your team lead in a meeting, because some people who understands the intricacies can able to ask some question which you may not able to answer because you didn't understand the concept, you just know the concept. So to learn something to that kind of level, to internalized to understandable level, this is the channel. So please subscribe to learn everything end to end to the detail. And thank you for watching.